Hi everyone, this is the continuation of multi-threading and the operating system. We have already seen what is thread and what are the benefits of multi-threading, that is responsiveness, resource sharing and economy and scalability. And we have seen multi-core programming. In that we have seen what is the execution of concurrency and parallelism of a thread, and we have said single threaded and multi-threaded process. That is, if a process is running on a single thread and it is able to execute a single thread, it is single threaded process, and if multiple threads are concurrently running on a process, it is multi-threaded process. Today we are going to see the continuation. It is about the user thread and kernel thread. User thread is managed by the user level libraries. Okay, three primary thread libraries we are usually using are POSIX pthread, Windows pthread and Java pthread. These are user threads. And the second one is kernel thread. Kernel thread is, these threads are supported only by the kernel. User level process is not responsible for these threads. These are known as kernel threads, and these threads run only on the kernel OS. Okay, we have already seen mode of operation right? In that, kernel will be executing these threads. Examples of these kernel threads are Windows, Linux, Solaris, Unix, Macs. These are the kernel OS supported threads. Okay, these are generally done by the operating system. Kernel is nothing but the operating system. As the continuation, we are going to see about what are the models of multi-threading process. There are three major categories of multi-threading models. One is many-to-one, one-to-one and many-to-many. Many-to-one. In this, many user-level threads are mapped to a single kernel thread. This is known as many-to-one model. In this, one thread blocking causes all the threads to block. Multiple threads may not run in parallel on multi-core system because only one may be in kernel at a time. Because even though there are multiple user threads running in a single kernel, only one can be run in a kernel level. Okay, only few systems can concurrently use this model. Others does not support this. The example of these few systems are Solaris Green Thread and GNU Portable P Thread. Okay, in this you can see this is the diagrammatic representation. These are the user threads. There are 4 user threads which was connected to a single kernel thread. Even though 4 user threads are connected in this, at a single time only one user thread can be executed in the kernel. This is the many-to-one model. And second one is your one-to-one model. In this one-to-one model, each user thread will be connected to an individual kernel thread. Okay, each user level is mapped to a separate kernel thread. One kernel is not supported by more than one user thread. Creating a user level thread and creates a kernel thread simultaneously. This is more concurrency than many-to-one model because each user thread can run simultaneously in an individual kernel. Okay, the number of threads per process sometimes restricted due to overhead, because as the number of user thread increases, the number of kernel thread also increases in this one-to-one model. The examples of Windows, Linux, Solaris. Okay, in this, as you can see, this is the diagrammatic representation which indicates the 4 user threads are mapped to 4 kernel threads individually. Okay, and finally is your many-to-one model. In this many-to-one model, many user threads are connected to many kernel threads, but there is no an individual way for connecting this thread. Okay, if you see this 4 user threads are mapped to 3 kernel threads, that whenever a kernel is free, the user thread can run on that individual kernel. Apart from this, not individual kernel is mapped to specific user thread. Okay, in this, many user level threads can be mapped to many kernel threads, which allows operating systems to create number of sufficient kernel threads. The example is Solaris is prior to the version 9. windows with thread fiber package are the examples of this many to one model. Okay, and this is two level model, that is it is the combination of more than one model, that is many to one, many to many, one to one. Any combination of these models are compared as two level model. It is similar to M to M bounded thread, that is whatever the kernel thread and user thread can bind in more than one category.